All right, one quick note here. It's been a few days and I'm dubbing over the audio of this video because we lost the audio portion of this after OBS crashed. And I'm not going to be making any attempt to sync up the video with the new audio. So the audio is going to be out of sync with the video. But anyway, I believe I was talking about here the biology of the human eye, and then I was thinking about with these left-aligned, right-aligned, and center-aligned signals, I imagine if you were to like take a microscope, this is my hypothesis, my theory here. If you were to take a microscope and zoom in, on the LED package, so you see the individual red LED, blue LED, and green LED. And then you were to record video at like, hundreds of frames per second, thousands of frames per second, whatever you need. And then slow it down. So you see in the video the individual LEDs lighting up and blinking off and on, right? My hypothesis here is that because the signals are aligned differently, and depending on whether the PWM hardware is able to send these in parallel or not, which I'm not totally sure of, I suspect here that what we'd see is that the red, green, and blue LEDs are not actually lighting up at the exact same time, that they're not synchronized. But I think it doesn't matter because the human eye doesn't even perceive that they're blinking on and off because we see at a much lower frame rate. I think it wouldn't have any effect on what we perceive because we're talking about such a small time scale here. That's my understanding regarding those channels. And then anyway, here we see in the video, we're looking at the PWM1 reg PWM CFG line, and we set enable always, and we set compare to center. So we know the compare to center is doing the setting up the center alignment for one of the channels. So it's the second channel that we're setting to be centered, and then we set the count to 0, just to zero it out. The video that I'm watching here, the playback, isn't totally synced up with the audio that I'm recording either. So right now I'm looking at documentation. I don't know if you are, but okay, we're back to the code here. So we zero out the count. So it was saying how the period is approximately 244 hertz, and we saw in the documentation that that would be the like the fastest it goes, basically. And then it also talks about how the LEDs are intentionally left somewhat dim. I don't know if we really saw that in the code here yet. But then we set the PWM compare 0 to 0. And again, we're zeroing it out so that we set on just the stuff we want, right? We just make sure that there's not other stuff that's on that we didn't intend. And then we have the IOF select and the IOF enable. And those two are like the select is the multiplexer, the muxer, that's responsible for deciding what functionality we want to use the pins for. So we're setting that on the pin that's for green, blue, and red, those 3 different pins. We're saying we want those to be used rather than for GPIO, like input and output stuff. we want to actually use the PWM hardware. So they're going to be generating PWM signals to actually control an LED on the board. And the IOF enable is just enabling the I/O on those 3 pins as well. We also have a few lines that are doing output exclusive OR, which I believe we talked about in a previous episode, how there's actually hardware to invert the output. And we see that we're turning off the bits for green and blue. So the one we're inverting is the red pin. So what that means is, and you see that's the second output exclusive OR line there. That's being done so that the red LED is left aligned, the signal is. Because we saw that in order to left align, we invert the signal. By default, it's right aligned, and to get center alignment, you needed to set that bit in the config register, which we did for the other one there. So by doing this, what we've set up is each LED pin is a different alignment, and it says that's to balance power consumption. I don't really know how it's balancing power consumption. Apparently there's different circuitry being involved, and by having each one have a different alignment, we're spreading out that work across different lines of circuitry, and that's balancing the power consumption. That's my understanding. We'll obviously get a much clearer picture if we actually look into the power consumption, as in if we actually look into the hardware and see how the hardware really works, which we can do since it's open. And yeah, I think if we do that, we'll get a much better understanding about what they're talking about in terms of power consumption there. Anyway, we go to the while one loop. And so the first few lines are pretty, basic, what we'd expect of setting up the now register and the then, so that it'll go off when now is less than then. We're just using a variable for then. We're saying now plus 100, and they're marked volatile. And of course, because they're volatile, the compiler can't optimize this stuff away, but we're just doing a busy loop where we don't do anything in the loop except compare now and then. And because now is actually a memory mapped register, it's going to be changing every cycle, right? The value in it is actually changing even though we're not doing anything in the code. And as a result, that line is just going to wait for the 100 cycles that we specified in then. So we're not actually using the CLint hardware there to do an interrupt. We're simply using it to do a busy loop. It's like a simple sleep implementation, right? So it's just blocking the thread for that amount of time. We also have below that some if statements that are controlling these RG and B variables. So you see that in one section we decrement R and increment G. In the next we decrement G and increment B, and in the last we increment R and decrement B, and those are all on various conditions that can happen. And this is controlling like the pattern of the fade that happens. So we'll need to think about that in more detail of exactly how that's going to affect the pattern, like of the fade that's going to happen. I didn't really think through the logic when I recorded this video, so I'm not going to have time to think through it, I think, in my dubbing here, but yeah, that's just the logic to control the fade. And then interestingly, we have these 32-bit registers, G, R, and B are 32-bit variables, where the lowercase g, r, and b were 16-bit. The uppercase are 32-bit. And you see below that, we do some bit manipulation, setting the PWM compare 1, 2, and 3 registers. So that's something that I don't understand yet. We see that we're doing G shifted left 4, B shifted left 1, shifted left 4, and 0x FF minus R shifted left 4. So that's confusing to me, why we're doing those things. I know the compare 1, compare 2, and compare 3 registers are for making the PWM signal, like, it makes the signals more complex. My understanding is that we can generate arbitrary waveforms by doing different manipulations on those different compare registers. So again, I didn't think through the logic of what's happening here yet in this video recording, but that's something we're definitely going to have to go back to and study to really understand what's going on there. And then the last thing we get to is the check user input. So we implemented in this little program the get character and the put character. So the get character is actually non-blocking. And I think I'll spend more time in this video in a little bit looking over that implementation. We didn't look at it in detail, just enough to understand what's going on here in this section of the code. So we say if C is 0, then we get character, and the return value actually tells you whether or not you received input. So it's a non-blocking call, and it actually puts the value it received in C. So then we do the put character C. So we're writing it out to the screen, and then we write the new line. So in the video here, I'm currently jumping around the code. So I saw that we earlier we print these ASCII diagrams, little pieces of art here, and then after that we're asking for input. We ask whether we are seeing the output or not, and the code for some of that is commented out here. You see it originally put the Sci5 message and the LED message, but I commented that out, and then there's some stuff I put in there, like in between those two lines, and those are commented out. So there's just a big block of commented out stuff there. It's only the first line and the last line of the commented out stuff that was in the original code. The other 3 lines are things I wrote when we were playing with the config string and the board ID and that stuff. So, but yeah, that's how that works. You see it asks, are the LEDs changing, yes or no? And then it has the art there, and there's new lines I remember I was looking at something about the new lines. I don't remember. Oh, I was wondering about that that third commented out line of mine where I was putting a new line and wondering if that was in the original or not, but it was not in the original because you saw in the actual strings that we originally printed that they have new lines in them. So that was from my code. But anyway, so we get a character and we put the character we got from the keyboard on the screen. So you see the output of, you know, what we're doing there. Here I'm looking at the get character implementation. We see it takes a pointer to a character in and it returns an int. It returns 1 if the value got in is greater than 0. Otherwise it returns 0. And then the actual value of the character we end up putting in the pointer there as an output parameter. So anyway, we put the character and then we do a new line. And then we check if the character is yes. So if it's a Y or a capital Y, then we print pass, and otherwise we print fail. And then I guess because it checks if the character is 0 before this, it only does it once. So because after we receive a character, C is not going to equal 0 anymore, so that code path wouldn't be taken as the program loops after we've done something once. And that covers everything in the code there. We just need to review, get a good understanding of what's going on in the actual changing the pattern that we do with the LEDs using that the code there that's doing the R minuses and the G pluses and so on. And then we need to understand the shenanigans going on with those compare registers. I'm not sure how much time is left in this video here. If I went over anything else, it's got to be near the end, right? Oh, did I accidentally close that, or did it actually end? That might have been the end. Anyway, thank you for watching. I'm going to cycle through this really fast just to make sure. Okay, yeah, that was the end of the video. So thank you everyone for watching. There were obviously technical difficulties in the production of this one, but thank you nonetheless for watching on YouTube Archive. It's going to be available there, which is at risky.tv, and you can follow me at HMN_risky to get updates about the series. I complained to my ISP about the networking problems I've been having here, which is why this video needed post work done on it, because OBS, that's another issue. Apparently this version of OBS crashes when your network goes down, and that's been giving me a lot of trouble due to the troubles I'm having in turn with my ISP. But hopefully my ISP gets this sorted out, and we'll have better, more stable internet the coming days. But anyway, stay risky, everyone.